Hi guys, we're going to get started with lesson 1.5 today. We're going to be talking a lot about angles today, okay? So we're going to get started by talking about types of angles. How do we classify angles? So we can classify an angle as being acute, right, obtuse, or straight, which I know those are not new terms for you guys, but as a quick review, acute angles have to be greater than 0 degrees but less than 90. So here's an example of what an acute angle might look like. A right angle is 90 degrees. We always look for that right angle box indicating that it is for sure a right angle. We can't just say, oh, it looks like a right angle. It has to have that marking, or you have to be told it's a right angle. Obtuse angles are greater than 90 but less than 180, and then a straight angle, a straight line, is 180 degrees. Okay, before I move on to the angle addition postulate, I want to talk about naming angles here, and I'll talk about it again. If I was to name this angle, I could name it. If you were to trace it, you could go from point A to B to C, right? If you were going to draw it, you could go like this. So I could call that angle A, B, C. I could go the opposite direction as well. I could go from C to B to A. Angle C, B, A. Notice both times the letter B, that is in the middle. Your vertex letter should be in the middle. So again, you could name this angle, think about tracing it, ABC or CBA. You could reverse the letters, and that would be appropriate. There is another way to name this angle. You could simply call it angle B and just use the vertex letter. Now, there is a certain situation, which I'll get to in a minute, where you can't use that vertex letter. The last way, if there's a number right there, that number is there so that you can name the angle as well. So since I just put that 1 there, I could call this angle 1. Now, if there is no little number, you cannot add your own numbers to the diagrams just to make it easier for you to name the angles. You can only use that little number to name the angle if it's already provided for you. Okay, now just continuing on with naming the angles. In this diagram, I could talk about the big angle, right? I could talk about angle RST, which I'll use a black marker since that was drawn with a black marker. So I could call the big black angle, angle RST, or I could reverse the letters, leaving the vertex letter in the middle and call it angle TSR. There is no number, so I can't name that angle based off of a number. I also can't call it angle S. Okay, and I said I was going to talk about situations where you can't use the single vertex letter. The reason I can't say, hey students, look at angle S, is because S is the vertex of the big black angle. It's the vertex of this red angle. It's also the vertex of the blue angle. So since it's a vertex of more than one angle, I can't just use that letter to name one of the angles, okay? Moving on to the red angle, I could name the red angle, angle RSP. That's this angle right here. So angle RSP. Or I could trace it in the reverse order and name it angle PSR. The vertex letter is in the middle. It's the only two ways to name the red angle. And finally, the blue angle, I could name it angle TSP. Or I could name it angle PST. And I just put a smudge on my diagram. All right, so that is how you name those angles there. It's the only options for the black, the red, and the blue angle. Okay, naming the angle is important. This little symbol, that's just an angle symbol. You won't always see the arc put in the angle. I do that so I don't confuse it with an L or a less than symbol. But you might see in your textbook just the angle and then RST. It's the same thing. I just put a little arc on mine so that I don't confuse it with a less than symbol or an L. Okay. All right. Now, one more thing on notation. If I want to say that two angles are congruent to each other, okay, for instance, if I was to draw, I'll just draw two quick angles. I'll make them both right angles. I'll call this A, B, C, and then E, F, and G. If if I wanted to say that those two angles were congruent to each other, I would say that angle ABC is congruent to angle EFG. If I wanted to say that their measures are equal, meaning that they're both 90-degree angles, I would put an M indicating measure. So the measure of angle ABC is equal to the measure of angle EFG. So if you see the M's, that's talking about the measure, and then you should have an equal sign instead of a congruency symbol. Right? So that's just a little note on notation. All right, so I kind of went off a little bit because I wanted to make sure I gave you that information, but I want to talk about the angle addition postulate. It's very similar to the segment addition postulate. The angle addition postulate says that you can take a small angle, my red angle, the measure of angle RSP, take my red angle, add to it the blue angle, PST, and when I add that red angle and the blue angle together, it forms the larger angle, angle RST. Okay, so we're going to be using the angle addition postulate in the next set of problems. Let me kind of erase and get started with that. All right, so for this example, if the measure of angle 1 equals x plus 15, the measure of angle 2 equals 2x minus 5, and the measure of angle ABC equals 4x plus 7, I want you to find x. So now I got to draw a diagram for you. So the big angle is A, B, C, and then I have D out here. Okay, so let's label everything that was given and then think about the angle addition postulate. Okay, so, I forgot to add the 1 and 2 as well. This is angle 1, and this is angle 2. Again, that was given. I'm not just making that up. That was given for this problem. Okay, so the measurement of angle 1, this angle right here, that's given as x plus 15. Okay, that's this angle here. Then you're told that angle 2 is 2x minus 5. So from here to there, oops, sorry guys, that is 2x minus 5. All right. And then angle ABC, so ABC, they're talking the large angle, the entire thing. That's 4x plus 7. Okay, so you first want to think about the angle addition postulate. The angle addition postulate says that the measurement of angle 1 plus the measurement of angle 2 equals the whole angle, which is ABC. So it really just becomes substitution and then an algebra problem. Angle 1 is labeled as x plus 15. Angle 2 is 2x minus 5. And angle ABC is 4x plus 7. So combine like terms on the left side first. X plus 2x is 3x. 15 minus 5 is 10. Now you want your x's on one side and your constants on the other. So I'm going to subtract the 3x from both sides. So everything stays positive. Subtract the 7 from both sides. That cancels. That cancels. So 10 minus 7 gives you 3. 4x minus 4x minus 3x gives you a 1x, so you know x is equal to 3. Double check that you answered the question. The question said find x. We found x. If the question had said, what's the measure of angle ABD, I'd have to plug 3 in here to find that this angle is 18 units. If I was asked to find the measure of angle DBC, plug in 3, that would be 6 minus 1 to give you a 1 degree angle. Or if I wanted to find the measure of ABC, plug 3 in here, 12 plus the 7 to get an 18. Okay. All right, let's move on to another problem. All right. Next, we're going to talk about an angle bisector. Okay, we talked about a segment bisector. Remember, bisect, when you hear bisector, you're going to think cuts in half, cuts into 2 equal parts. So when we bisect a segment, the segment is being divided, broken into 2 equal parts. When we bisect an angle, you're taking a bigger angle and breaking it into 2 equal angles. Okay, so let me write down the definition first. Angle bisector. It's a ray that divides an angle into 2 congruent angles. Okay, so for example, if we had a big angle, we'll call this X, Y, Z. If X, Y, Z was a 60-degree angle, okay, let's pretend that that's 60 degrees. And then we bisect it. We take a ray and we cut that in half. So I take a ray and I divide that in half. We'll call that ray YW. Well, what's formed now, instead of one 60-degree angle, I have 2 30-degree angles. Okay? All right. Oh, to indicate that they are congruent angles, so you know how when we have a segment, I said if you have, let's say we have a segment A, M, B, to indicate that M was the midpoint in the middle, we use little tick marks, right? And we could say that AM is equal to MB, or segment AM is congruent to segment MB, right? So for angles, what we do is we use one arc on that angle and then the same number of arcs on the other angle. In some textbooks and worksheets, you might even see an arc with one little dash, right? Okay, and then again, notation-wise, I could say that the measurement of angle XYW is equal to the measurement of angle WYZ. Or I could say that angle XYW is congruent to angle WYZ. Okay, again, emphasizing that notation. Okay, so now let's do a problem related to an angle bisector. All right, so for this problem, it says that NP, ray NP, bisects, cuts in half, that's how you need to read it when you read it in your head or out loud, the angle MNS. All right, and then you're also given that angle MNP is equal to 3x minus 1, and angle PNS is equal to 2x plus 5, and you're asked to solve for x and find angle MNS. All right, so let me draw the diagram and then we'll get started. So M N S, and this is P. All right, so let's kind of read through again and mark up what we need to mark up. As soon as I read that Ray and P, so here's Ray and P, as soon as I read that it bisects angle MNS, I know the big angle is being cut in half. So I would go and I would mark this one congruent to that one by using the same arcs, okay? Then I'm told that MNP is being represented by the expression 3x minus 1, and that PNS is being represented by 2x plus 5. All right. Then I'm asked to solve for x and then find the measure of the big angle. Now, be careful. When we use the angle addition postulate, like we did in the last problem, we were given 3 pieces of information. You were told this angle, and the whole angle. I know nothing about the whole angle, so I can't say that this one plus this one equals something because I don't know what it equals. I don't know the measure of the big angle. But I do know a relationship between these two angles. They are equal to each other. Okay, so when I'm using the angle bisector, you're going to be setting two things equal to each other. You know that the measurement of angle MNP is equal to the measurement of angle PNS. Okay, right? We've marked them equal to each other because of that word bisect. So now I can substitute 3x minus 1 in for the one angle and 2x plus 5 in for the other angle. I'm going to subtract 2x from both sides. I'm also going to add 1 to both sides. So I have 1x is equal to 6. X is equal to 6. Now you're asked to solve for x, but then you're also asked to find the measure of MNS, which is the big angle. So let's go back and do some substitution. If x is equal to 6, 3 times 6 is 18, minus 1 gives me 17 degrees. Since these are equal, this one should also be 17, but let's make sure. Plug in the 6. 2 times 6 is 12. 12 plus 5 is 17. And that means the whole angle addition postulate, this angle plus this angle equals the whole thing. 17 plus 17 is going to give you 34 degrees. Okay, so the measure of angle MNS is equal to 34 degrees. All right, and I believe, let me just quickly take a glance. Make sure I have it all. Yep. That is it for this lesson. All right, so make sure you get your notes done, and I'll see you back here for the next lesson. Bye.